All right. Hi, everyone. My name is Krista Rosas, and my partner here is Andy Anzaldua. And our topic today is fats, oils, and emulsions.
All righty. So today we're going to talk about some key terms that you're going to need to know for your lab that's coming up this week. So the first term that we have is smoke point, also known as the burning point. When fats are exposed to high temperatures, they break down, causing the fats to reach their smoke point. So let's say you use an oil that has a really low smoke point. Whenever it reaches that and exceeds that temperature, it's going to start smoking. And that at that point, it actually can release bitter flavors into your food. So you just want to be wary of the smoke point of some oils, just because they will affect the flavor in the end. Hydrogenation. So this is the conversion of unsaturated to saturated fats through the chemical process of adding hydrogens to oil in order to remain solid at room temperature. This hydrogenation process creates trans fats, and these are present in margarine, fried foods, and processed foods. Finally, we have surface tension, the cohesive forces between liquid molecules. So, for example, whenever you fill up a glass of water and it goes all the way to the brim, and you have that little dome of water that's on the very top, that is the surface tension right there. So it is those, the forces between those molecules, they want to stick together because like bonds like. And finally, we have emulsion. This is the mixture between one liquid and another in which they are both normally immiscible and causes a dispersion. We're going to talk a little bit more about emulsions a little bit later, but basically it's just two liquids that are whisked together or beaten together really fast, and it just basically causes them to combine. Again, we'll talk about it a little bit later. So functions of fats in foods. So fats are really useful in the kitchen. They allow heat transfer. They offer shortening power and plasticity. You have emulsions as well, flavor, satiety, and texture. So heat transfer. Hot oils can transfer much of their heat energy to food while not overcooking the interior portions. So let's say you got a piece of fried chicken and you want to make it fried and you want to submerge it in oil, right? So you heat the oil, submerge it, and whenever you submerge it, the chicken is completely getting heated very evenly, right? And that is to basically allow the moisture in the inside of the chicken to get heated, and it basically causes the cooking to go get just cooked very evenly, basically. Shortening power and plasticity. Fats have the ability to make baked goods more tender because they inhibit gluten development. Some fats can also be very spreadable and formed into shapes depending on their temperatures. Emulsions. Fats can combine with water to become emulsified. This usually results in a thicker and creamier texture. Flavor and satiety. Fat is responsible for flavor in most foods. Fat also plays a role in satiety because fats take longer to digest than carbs or protein, making you feel fuller for longer. Finally, we have texture. Texture is, fat is responsible for many types of textures, such as tender, crunchy, or creamy. Whether it be for deep frying or for baking, fats give a lubricating mouthfeel.
All right, so now we're going to talk about deep frying with fat. So deep frying occurs using liquid oil at high temperatures and smoke point. So the ideal frying temperature is 350 to 400 degrees Fahrenheit. Time, temperature, and the surface of the food is essential when learning to deep fry because you want to cook the inside before crisping the outside. So this is the key to successful frying. And here are some of the smoke points of commonly used oils and butters. Extra virgin olive oil, 325 to 375 degrees Fahrenheit. Butter, 350 degrees Fahrenheit. Canola oil, 400 degrees Fahrenheit. And sesame oil, 350 to 410 degrees Fahrenheit. And peanut oil, soybean oil, and clarified butter all have the same temperature to 450 degrees Fahrenheit. All right, so now we're going to go more into detail. And liquid oil at high temperatures with smoke point is a preferred way to deep fry. While the boiling point of the oil is reached, food submerged into the oil will then create bubbles that will vaporize water out and inside the food, thus allowing the oil to travel in and further cook the food in the inside. So another method of cooking is battering before frying. And this prevents excess grease and oil to be trapped within. So this technique also prevents overly drying the center as it obstructs oversaturation through a second layer, acting as a separation between the fat and the food. And some other common frying mistakes are overcrowding the fryer, oil not hot enough, and too hot of oil. And all of these mistakes can cause food to stick together, get soggy, or not crisp up enough, and it will not be a good texture or crispy enough.
Alrighty, so we have the use of fat for shortening. So shortening can be used as a fat in cooking to create a crumbly or crispy texture on items such as pastries. Fat has the ability to inhibit gluten development by breaking down gluten into shorter strands, hence the name shortening. Plasticity within fats also comes to an advantage when creating icings, pastries, and confections, as it can be shapeable, spreadable when working with special foods. So for example, as you see in the picture, we have a cake here, and basically that icing on the outside can hold its shape. So therefore that means that it can stay on the walls of the cake. So for example, we have croissants. So this is an example of how fat is able to inhibit gluten development. So when you're making croissant dough, you actually have to put a lot of butter in it. And so whenever you're basically kneading the dough and creating layers in the dough, that butter is evenly separated. So it's basically just trying to get as much butter in there as possible and mixed into the dough. And so whenever you bake croissants, they don't really rise, but they just get really, really flaky. They get really, really tender and flaky. And that is just all that fat. It's basically inhibiting the gluten development in there. And so basically, but that is what gives you that good texture that you want in a croissant. So some commonly used shortenings are butter, margarine, vegetable oils, and lard.
Okay, so you may be thinking, what is shortening? So shortening is a cooking fat solid, and it's under room temperature, which creates it super solid. And this serves as a pastry dough-like form and does not have any odor or flavor. This type of solidified fat can come from oils, lard, butter, or margarine, and which are hydrogenated to become trans fatty acids. Shortening can also behave as a coat surrounding the food, acting as a barrier to lessen the amount of absorbed oil and grease due to its high melting point. So as you can see on the left, that is shortening, such as Crisco, and it's added to foods, and it helps basically with the crisping up and preventing the inside from burning. So, and you may be wondering, what is hydrogenation? Hydrogenation is a chemical reaction in which transfers molecular hydrogen to oils in order to produce more of a saturated-like texture. And the addition of hydrogens allows the breaking of cis double bonds from an unsaturated fat to form a trans bond. And this creates trans fatty acids, which thicken and are able to become more solid at room temperature. So basically, these oils that are unsaturated are then added with hydrogens to create trans fatty acids and become saturated and solid at room temperature.
All righty. So now we're going to talk about the use of fats in emulsions. So an emulsion is a mixture of an oily and watery liquids. So emulsifier molecules work by having a hydrophilic head and a hydrophobic head. The forces of mixture causes the hydrophobic ends to be attracted to, the hydrophilic ends, to be attracted to water, and the hydrophobic heads to be attracted to the fat or oil. Some common emulsifiers include egg yolk, mustard, canola oil, and mono and diglycerides. Some temporary emulsions. So these are two liquids that stay together for about an hour before reseparating. This could be really fast, honestly, something like a vinaigrette. So you'll shake it together and it'll mix, but in the end, it's going to reseparate. Semi-permanent emulsion is an emulsion that separates only after a couple of hours. So this is just a little bit longer of a time frame. This usually is explained by a hollandaise sauce. And then we have permanent emulsions. This is an emulsion that does not separate. So a good example of this is actually mayonnaise. To make an emulsion, it requires two things. The emulsion itself, so this can be when water gets dispersed into fat or oil, or vice versa. So this could be fat or oil that gets dispersed into water. And also you just need a force, such as whisking or beating. The force applied to the emulsion acts to break the oil droplets apart so they mix with the watery liquid. And finally, we have some storage of fats. So we have rancidity. This is a condition produced by aerial oxidation of unsaturated fats present in foods and other products. Rancidity is distinguished by an unpleasant or odor or flavor. Finally, next we have oxidative rancidity. So this is the double bonds of an unsaturated fatty acid can be cleaved by free radical reactions with oxygen. These reactions release malodorous and highly volatile aldehydes and ketones. So this all sounds fancy, but oxidative rancidity is basically when these fats become in contact with oxygen. They cling on to the free radicals, and next thing you know, they start releasing these compounds. Hydrolytic rancidity refers to odors that is developed when triglycerides are hydrolyzed and free fatty acids are released. Again, a lot of fancy words in there, but in the end, it's just when triglycerides come in contact with water. So basically, try not to get your fats near any water. So to prevent rancidity, fats and oils should be stored in cool temperatures until in use. Oils and fats should be kept in airtight containers to try and maintain the amount of oxidation that occurs within the fat molecules. So also another thing to note is that sometimes UV rays can actually impact how fats get oxidized. So yeah, just make sure that you keep your fats in a nice, cool, dark, safe place, preferably airtight, and you'll be all good to go. And here we have some questions. So Krista?
All right, so here are some review questions from the previous slides that we went over, and to get your brain going and learn about fats. So what type of fats have the best shortening power? Unsaturated fats, saturated fats, or polyunsaturated fats? Next question, what is the ideal frying temperature? 350 to 400 degrees Fahrenheit, 215 to 290 degrees Fahrenheit, or 400 to 450 degrees Fahrenheit? And next question, what is the best example of a permanent emulsion? Kool-Aid, mayonnaise, or honey? And we'll give y'all a few seconds to kind of go over it and think about it. Alrighty, so here are the answers, and the best shortening power of fat is saturated fats. And as far as the ideal frying temperature, 350 to 400 degrees Fahrenheit is prime. And as far as the best example of a permanent emulsion is mayonnaise. So thank y'all for, next slide is references. Sorry, y'all.
Our references, yeah. That was our presentation. Everybody, thank you. Hope you have a great lab this week. And thank you very much.
Thanks for watching.